Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God willing, in this tutorial, I'm going to show you how to perform two-way analysis of variance, also known as two-way Anova in R. As you can see here, I'm using R Studio as an IDE for R. So quickly, I have a hypothetical data that I'm going to work on here. As you can see, I have some outcomes here. 35:22 down through 36:15, okay, for the 7 days of the week and three towns: town A, town B, town C. Okay, so this is assumed to be the outcome, okay, for a particular yield of crops across the 7 days of the week in three different towns. Okay, remember the objectives of two-way analysis of variance is to test if there's significant difference in the outcome here in this case across the days, as long as the town, and sometimes for the interactions between days and towns. So quickly, I'm going to show you how to enter the data into R and how to perform the statistical analysis. So the first thing you need to do is to define your variable. So all you have to do is permit me to maximize this time around. I'm maximizing it. Remember, you can actually enter your data using the R script here or the R console, okay? So either ways, your result is going to be the same and correct. So like I said in the tutorials on one-way analysis of variance, I said I prefer using the R script so that you can easily see the line of codes you performed, as well as you being able to share the source file. Okay, so quickly let's see how to perform that. Permit me to split my screen again once more. So I'm going to define the variable, and our variable here, our dependent variable here, is the outcome, right? Hypothetically, so let's say I have a variable called outcome, assignment operator here. Then remember, you have to concatenate it because you're trying to tie them together, saying they are vector. So quickly here, you can actually enter your data either row wise, column wise, row wise here, or column wise, as well as randomly, maybe 28 first, before 21, before 35, before 24, either ways. But ideally and more realistically, as well as for simplicity and running away from ambiguity, all you have to do is, preferably, you need to use either row or column wise so you won't make a mistake, okay? But should you know what you're doing, you can actually use the random approach, but it is actually not advisable, okay? So for the sake of this tutorials, I'm going to apply the row-wise approach, right? So quickly here, for the first row, I have 35, 22, 29, and so on and so forth down to 40. So for row 1, which is for town A, I have records such as 35, 22, 29, 35, 21, 31, 40. That's for row 1. Then for row 2, I have 29, 31 down to 16. It means I have 29, 31, 28, 17, 26, 32, 16, right? Then for row 3 here, that's for town C, I have 17, 35, 40. So you'll enter it the same thing: 17, 35, 40, 27, 24, 36, and 15. Okay, if you're done with entering it, then you hit your enter key. So I have outcome here. You can maximize it to see it contained it, right? Can you see it? expand this selection. See, it contains everything. So permit me to split once more. So the next thing is I need to define the column. So for the column, which is a factor, I have Monday, Tuesdays, Wednesdays through Sunday, and it's days of the week. So I can call it, let's say, days. My assignment operator. I have my assignment operator this time around, but because it is a factor, I need to declare it using the as.factor function. As.factor, okay, open bracket, meaning I'm saying the days is a factor, so declaring it as a factor. But remember, you'll have to concatenate it inside again, concatenating the entries. Now for the days, to enter it into the vector here we're creating, all you have to do is you check. Since we entered it row wise like this, my bad, since we entered it row wise like this, here as you can see 35 appears under what, Monday, 27 for Tuesday, 29 for Wednesday, all through Sunday, right? So we can code, let's say, Monday with 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, Saturday 6, and Sunday 7. So this means that 35 falls under column 1, 22 column 2, 29 column 3, 35 column 4, and so on and so forth down through column 7. So if you agree with me, for the first row I have column 1, column 2, column 3, column 4, column 5, column 6, column 7, right? This means that 35 through 40 I have 1, 2, 3, 4, 5, 6, 7. Is that right? Now the next thing I have also is to go back to the next entries in the order in which I entered it. So you have to follow the order also, and this also falls under column 1, column 2, column 3, column 4, column 5, column 6, column 7. So it means I'll still have that pattern again: 1, 2, 3, 4, 5, 6, 7. Is that right? Comma. Then next thing again I have is 17 through 15, and this is for column 1, column 2, column 3, column 4, column 5, column 6, column 7. Meaning I have the same thing. You can copy paste if it is balanced. Okay, 1, 2, 3, 4, 5, 6, 7. But I usually advise my viewers and subscribers not to always copy paste, except if you know what you are doing, because sometimes if the number of replications are not equal, it will not be the same and you'll get a wrong answer when you copy paste everything, not taking cognizance of the number of replication. Okay, so the next thing is you hit your enter key, and all you have to do is you go to the next factor, and the next factor we have is town. So let's say we have a factor called town, defined by, it's also a factor, so we need to tell R that this is a factor. So I have as dot factor, then open brackets. So this is the function. Also we have to concatenate it. So in the same manner, all you have to do is you take cognizance of what you entered. You know, we entered in this order row wise, right? Now 35 falls under town A, which is row 1, 22 town A row 1, 29 town A row 1, all through 40 all town A row 1. So meaning I have 1, 1, 1, 1, 1, 1, 1 in 7 places, right? So if you permit me, I'll say 1, 2, 3, 4, 5, 6, 7. The same thing, the next one here, 29 through 16 appears in town B, which is row 2. It means you have 2, 2, 2, 2, 2 in 7 places in like manner. So quickly I have 1, 2, 3, 4, 5, 6, 7. The next one we have is 17 through 15, right? 17 here through 15, which is for town C, and that's row 3. Meaning we have 3, 3, 3, 3, 3, 3, 3 in 7 places. So it means I have here 3, 1, 2, 3, 4, 5, 6, and 7, right? So we've entered all the data. Hit enter key, go to line 4. All you have to do is now you instruct the R what you want it to perform. Okay, so quickly I'll maximize my screen so you'd see since we've entered the data. So I can maximize my screen, maximizing it now. So permit me to expand this, extend this a little. So quickly, now at this juncture, there are many ways of calculating or obtaining the two-way analysis of variance in R. Okay, so one of the ways is you actually use the AOV function. Another way is you use the linear model, which is LM function alongside Anova function, right? So I'm going to use the AOV function for the first approach. Now this is how I'm going to do. I want to put it in a variable container. So let's say I want to call the variable two-way Anova. Okay, my variable is two-way Anova, defined by, now the function is AOV, analysis of variance. Function AOV of what? My dependent variable is outcome. AOV of outcome on, then you use the tilde sign. This is a tilde sign. So permit me to show you the sign in Microsoft Word for easy understanding. So I'm going to type it here, tilde sign. Let me increase it. This is, can you see it? This is tilde sign. Okay, so use the tilde sign. So permit me to expand once more. So here I have the tilde sign. That means outcome variable on days and town. So here I have days and means plus town. Okay, so I have days and town. So all you have to do is you press your enter key. Okay, so the next thing we need to do is to use the summary function. Summary, make sure all functions in R are in lowercase, else you get an error message. Okay, summary of what? Summary of our variable container for AOV. So I have, which is two-way. As you can see here, is two-way. So I already have it here. You can just click on it. It's recording it for you. Two-way Anova. So that's all. If you like, you must not put it in a container. Here you can redefine the function and make it composite inside. Okay, so this is what you'll do. Select everything here. Now press Command Enter or Control Enter depending on the machine you're using. If you're using Mac, Command Enter. If you're using PC, Control Enter to run the code here. Okay, and it will show you the variables, okay, here too in the environment. So I'm running it now. So if you observe, I have it here. It's showing me outcome, this. Like I said, you can use the console if you like. And these are the values. We have days, a factor, we have week, we have outcome, numeric, and we have town factor. Okay, so like I said previously, if you don't want to create this variable here, maybe you want to have a composite function, all you have to do is erase the two-way Anova here and combine this in summary function. So let me show you how to. So all you have to do is, now I'm creating something else. Let me recopy it to make it fast and maybe go to line of quotes, line 10, and paste. So I want to delete this last two. So now I want to combine it together using the summary function. So I have summary of, this time around I have to define it. Okay, summary of AOV, open bracket. Now I'm defining it, outcome of days and town. Okay, That's all for that. See, this is a composite function. So then you select the lines of codes and press Command Enter. You see the outcomes, they are all the same too. As you can see, everything is the same. If you want, maybe probably you don't want to use Command Enter or Control Enter depending on the machine you're using. Let me copy and paste this very code again, maybe from line 16. All you have to do is, after selecting the code, you can use the run here, run key. Okay, run selection. So you press it again, you see the same answer. Okay, they have various ways of doing that. Okay, all right, so for the method 2, I'm going to use the linear model and Anova function, right? So remember, we already have our data. Permit me to copy just the data since you already know how to enter it. I've copied the data, I've pasted it here. So this is my data that is entered. So all I have to do again is follow the same procedure. Let's say I want to have two-way Anova, like I have it here. Let me just select, since I've saved it, to make it faster. Then my variable container. Then the function I want to use is LM linear model, because it can be a linear model too. Open bracket, dependent variable is outcome, your tilde, outcome on what? Days and town. Okay, then you hit enter. All you have to do next is just call it using Anova. So I'm using Anova function. Anova to call it. What am I calling? It's linear model. Okay, and it's in a variable container called two-way Anova. That means it's been assigned as a variable called two-way Anova. So two, you see, way Anova. All right, so I have two-way Anova. All you have to do again, you select the lines of codes and run using Command Enter for Mac users and Control Enter for PC users, or you can just come here and click on Run Code. Now after running it, if you observe, the answer is still the same here. As you can see here, it's still the same with everything. Our response is outcome. Okay, so also if you want to use the Anova function directly without using this variable container here, maybe you want to have a composite function, all you have to do is, let me copy paste the data set here. So I have my data. Let's say, let me go to another line of code. Here I have my data. You press enter key. All you have to do is use the Anova directly, the Anova function, open bracket. But in this case, I'll need to have another function inside, which is LM for linear model, open bracket, outcome, which is our dependent variable on your tilde sign, what, days, and, which is plus, town. Okay, so all you have to do is you go down, you see the next line of code, you are through with your codes, right? So you can select the code you want to run. So I want to select this one I just did. Observe again, the answer will still be the same. So I'm going to use Command Enter. Since I'm using Mac, you can use the run button here, or Control Enter if you are using PC, either ways. So I have Command Enter. Observe again, the values are still the same. Can you see it? Still the same. So we have different ways and approaches of obtaining two-way analysis of variance in R. Okay, so I hope you understand all this method. The whole essence of this repetition or approaches is for you to understand the various ways of obtaining that. Okay, so I hope you like this video. Kindly like, share, subscribe, hit on the notification bell for more updates. Thank you for watching.